So we've been talking about solutions, and we just talked about what solutions are made of, the solute, the solvent. Now we're going to talk about solution properties and electrolytes, how solutions ionize, all that. So strong electrolytes, they ionize completely in water. So strong electrolytes ionize completely in water. They're always ionic. Another term that you'll see used for ionize is dissociate. So ionize and dissociate are the same thing. So they form ions. Dissociate, kind of a fancier term if you want to think of it that way. But dissociate means to form ions, to form charged species in a solution. So I'm going to put both of these mean the same thing, to form ions. So if you think about Gatorade, Powerade, all these different sports drinks, that is a type of electrolyte replenishment therapy. So they have ions dissolved in this solution, and that helps you get hydrated. Here are reactions that you will be asked to predict. And these, in the beginning, are going to be simpler. In the end, they're going to get a little more complicated because you'll have to think about solubility rules. But for right now, when you see an ionic compound, it's going to be, this is before the reaction, before you put it in water. It's solid. When you put it in water, what's going to happen to it? It's going to do two things, right? It will dissolve and it will dissociate or ionize. So, just like we did before, dissolves and then it ionizes. So, sodium chloride is going to be sodium +1 aqueous plus Cl -1 aqueous. So, if you think about electricity and water, electricity and water don't mix, right? That's because there are little charges in water that can conduct electricity. So strong electrolytes conduct a lot of electricity. So if you had a choice of which type of solution you wanted to drop your hairdryer into, you wouldn't want to pick a strong electrolyte or a weak electrolyte. You would want to pick a non-electrolyte that doesn't conduct any electricity. So we'll see in lab. We have a probe that measures how much electricity a solution conducts, and so you can classify it as a strong electrolyte, weak electrolyte, or non-electrolyte. So here's another reaction, and we will give you the formula. I'm just trying to stimulate that Unit 2 material when I say solid aluminum nitrate. So I've given you the name, and from the name, you can write the formula. So aluminum is in group 3. What charge does group 3 form? Yeah, so Al plus 3. And then, does anybody remember the formula for nitrate ion? NO3 minus 1. Good. So I'm not trying to put you on the spot. I'm just trying to get that retrieval. Okay. So what would the formula be using the cross and drop? Excellent. So it would have the S beside it. how is that going? So it's going to do two things. It's an ionic compound, so at this point an ionic compound is a strong electrolyte. When you put it in water, it's going to dissolve and then it's going to ionize. So what ions would you form? NO3 minus 1. So it's AQ, AQ. Now, we learned about balancing equations in Unit 3. Is this equation balanced? No, it's not. How would I balance it? We got 1 aluminum, 1 aluminum. 3 nitrates, 1 nitrate. Got 3 in front of just the nitrate. So when you're talking about strong electrolytes, all you have is ions. So it's all ions. So 100% ions. So weak electrolytes ionize to a small extent, unlike strong electrolytes. So ionize to a small extent. %, or less is how many ions you will have in solutions. 10% or less of ions. So most often, weak electrolytes are polar covalent bonds. All right, this is a Unit 4 review. Acetic acid. What's the structure of acetic acid? How many carbons? 2. So it's a carboxylic acid. Okay. So I drew that bond between oxygen and hydrogen explicitly to show you that that's the bond we're talking about, and it's polar covalent. So what happens, acetic acid is a weak electrolyte. Only ionizes to a small extent. That's why we use this double-headed arrow. You know those decisions that you're trying to make? They keep going back and forth, and you know you should really do this, but you still pull to, like, what if I made this decision? You know, that's what I think, how I always think of these arrows with the weak electrolytes. I'm not quite sure. So acetic acid's not quite sure whether it wants to be a molecule or whether it wants to be an ion. So right now, acetic acid on the left side of the reaction is a molecule. So molecule. It has the choice of whether it wants to be a molecule or an ion. And a lot of the time, it wants to stay a molecule. Some of the time, it wants to be an ion. So the ion that acetic acid forms, remember, it's an acid. And what acids do, and we'll talk about this later on in Unit 5, is they form, or they produce H+ in solution. So it goes to H+, And so acetic acid, depending on what you're dealing with, it could be AQ or liquid. So it goes to H plus AQ. And then what's left over if you have an H plus? Excellent. So you have a minus. So that's the other part. So it has, acetic acid has a choice whether to be a molecule or whether to be ions. Now, you guys know how to name this ion. This written a different, this I'll write it a different way and I'll see if you recognize it. Acetate ion. So it's kind of all coming together now, which is nice. You've got a little bit of organic chemistry, you've got your inorganic chemistry from units 1 and 2, and now you're kind of seeing how it goes together. So this is acetate ion. So if you ever find yourself in a pinch and you can't remember the formula for acetate ion, you say, I don't know, it's C2, is it H2 or is it H3? You could just draw out acetic acid, get rid of that H, and then you have your acetate ion. So these arrows mean you're dealing with a weak electrolyte. So this is not all ions. It's just 10% or less of ions. So this is, oh, I'm going to square this one. So strong electrolytes are 100% ions. Weak electrolytes are mostly molecules and a few ions. And whenever you're asked a question about weak electrolytes, if you see this double-headed arrow, this I can't make up my mind arrow, that means you're dealing with a weak electrolyte. So we'll see in our lab, experiment 22, conductivity lab. We'll see that. Okay, now the last class of electrolytes would be the non-electrolytes. Do you think they form ions? No. So no ions in solution. Works. So no ions in solution. These are all molecules. So if you had a choice, what solution to drop your hairdryer in? A non-electrolyte would be the best choice because it's not going to conduct very much electricity at all. So here's what we have. This is sugar. Sugar is not an ionic compound. But what do you know about sugar when you put it in water? It dissolves, but it does not ionize. So it dissolves, but it does not ionize. Well, that's what a non-electrolyte does. So what you're going to see is C6H12O6 go from solid to aqueous. But notice the absence of the charge. You don't have a charge, plus or minus, on this sugar molecule. It just stays neutral. So be familiar with these definitions: strong electrolytes, weak electrolytes, non-electrolytes. We're going to see some more reactions coming up. They're called dissociation reactions that work off of these definitions, and we'll kind of work these definitions in along with solubility rules. So Now we're going to talk about equivalence. And maybe you've seen this on IV solutions where it gives the concentration of a particular ion, but it gives it an equivalence. And you think, what is an equivalent? Well, equivalents are based off the charge of an ion. So depending on what ion you're working with, you might have a different charge to mole ratio. So we'll learn about that. So one equivalent is 1 mole of charge. So one equivalent is 1 mole of charge. This is the, I'm going to put this in a smaller definition, amount of positive or negative that an ion supplies. Amount of positive or negative charge that an ion supplies. So this goes back to Unit 1. Remember those prefixes, the mega, kilo, deci, centi, milli, micro, nano. One equivalent is how many milliequivalents. This is the same conversion as like 1 liter is how many milliliters. So milli means it would be 1,000. So one equivalent is 1,000 milliequivalents. And so sometimes you'll see milliequivalent used because it's a lot easier than saying 0.0023 equivalent or something like that. So
is that like in like nursing and everything in pharmacy where you see like 1 cubic centimeter is equivalent to 1
right. Except 1 milliliter and 1 cc are the same. So whereas one equivalent is different than milliequivalent by 1,000. But I mean, you see different units, depending on whether you're dealing with a large amount per liter or per milliliter. Okay. I'm going to go through some ions, and I want you to list their charge. So sodium is in group 1. What charge would it have? Plus 1. Calcium is in group 2. What charge would it have? Plus 2. Iron, 3. Plus 3. Chloride, minus 1. Sulfate. Sulfate is SO4 minus 2. So minus 2. Chloride, Fe plus 3, Ca plus 2, sodium plus 1. So the number of equivalents in 1 mole is going to be the charge. So if I have a charge of plus 1, then I have 1 equivalent in 1 mole. If I have a charge of plus 2, then I have 2 equivalents in 1 mole. If I have a charge of plus 3, 3. Yes, you're seeing the pattern. Good. Good, good, good. Now, this is the absolute value. So you're not going to say, if you have minus 1 charge, you're not going to say you have minus 1 equivalents in 1 mole. You're just going to say 1. And then, so the next one for sulfate would be 2 equivalents in 1 mole. So we're going to do some conversions on different solution information. And these conversion factors are useful, are easily mixed up. So if you have 1 mole of calcium ion, how many equivalents of calcium ion do you have? 2. 1 mole of sulfate ion, you have 2 equivalents of sulfate ion. What I want to say, and I always make this clear, is that 1 and mole always stay together. This is constant in your conversion factors. 1 and mole always stay together. What varies is the number of equivalents, and that depends on your ion that you're dealing with. So this is the number that will vary. Varies depending on ion. So a question that I could ask you, how many equivalents are in 6 grams of magnesium? No, she did not just ask a conversion question. I did. So this goes back to Unit 1 and Unit 2. Remember setting up conversion problems. Think about setting up your conversion roadmap, putting your starting quantity over 1. You don't want to. Yes, you have to. This is making your final studying so much easier. So it's a good thing, even though it might not feel like it. Okay, so I'm starting off in grams, and I want to get to equivalence. And the abbreviation for equivalence is capital E, lowercase q. So is there a conversion factor that we talked about that goes directly from grams to equivalence? No. What conversion factor do we know that involves moles? So we know how to go equivalence to moles. Do we know how to go from grams to moles? Yes. Yes, it might require some work to remember that, but yes, we can definitely go from grams to moles and then moles to equivalence. So what's our starting quantity here? 6.0 grams of magnesium over 1. How do I convert to moles of magnesium? Yes, the number in red on your periodic table. 24.31 for magnesium. So yeah, dust off your periodic table. So the molar mass listed for magnesium is the number in red. It's 24.31. And remember, when you pull that off the periodic table, it doesn't have any units, but you adding the units of grams per mole is very helpful. Grams per mole. And remember, when you write the slash, what you're really saying is that this is 24.31 grams over 1 mole. I have a lot of students who just want to write the slash and the units cancel out magically, but whenever you see a slash, if you write it out like this, it will make it a lot easier for you. So I don't want it to be confusing. So 24.31, in order to get grams to cancel out, where would I put that? In the denominator? Yes, to the bottom. So grams cancels out. We're still dealing with magnesium. So we have gone through this first conversion step. Now we need to convert from moles to equivalents. And this is based on the charge. And remember that I told you that 1 and mole always go together. The number of equivalents depends on the charge of the ion. So 1 mole is equal to how many equivalents for calcium? 2. So how would I convert from moles to equivalents? What needs to be in the denominator? What's it? 2 over 1, yes. 2 equivalents over 1 mole. So yeah, get your calculators out. So remember, when you're carrying out conversion problems, you multiply across on the top and then you divide on the bottom. So 6 divided by 24.31 times 2 gives you how many equivalents you would have. So I get 0.493624 equivalents. But I have to think about sig figs. I know you wanted to forget about them. But how many sig figs can I have? 2. So I'm going to put a bracket around this guy here. And will I round up or keep it the same? Keep it the same. So 0.49 equivalents. All right, so this next question. How many grams of sulfate ion are present in 3 equivalents of sulfate ion? So before you get lost in the numbers and calculating the molar mass and, ooh, I need to review Unit 2 and Unit 1, I don't know what I'm doing. I want organic again. Step back, take a deep breath, do your conversion roadmap. So what's the question asking for? What units? Grams. So that's at the end of my roadmap, right? Moles is in the middle. So yes, you can go grams to moles. And then from moles, you can work backwards to get your starting quantity, which is equivalence. Okay, so now I want you to try to set this up. What's the formula for sulfate ion? SO4 minus 2. So that's what we're talking about. What did you get for the molar mass of sulfate? 96.06. So you have 32.06 from sulfur, and then 16 times 4 gives you 64. So 96.06 grams per mole. The first step that we have to do here is convert equivalents to moles. So, when you're first dusting off the cobwebs from conversion, just think about the basic canceling things out. So equivalence cancels out, you'll be in moles. And then think about putting in your actual conversions. So remember we said 1 and mole always go together. And what are your equivalents for sulfate? 2. Excellent. Okay. So now I've gotten through this first step, equivalents to moles. Now I need to go moles to grams. So that's when I'm going to use this molar mass. The grams need to be on the top. The moles need to be on the bottom. So 96.06 is married to that grams. They're not going to break apart. They stay together. 1 mole. So on your calculator, you would enter 3 divided by 2 times 96.06. You end up with 144.09, and good. So you have 3 sig figs to begin with. You need to have 3 sig figs in the end. So you end up with 144 grams. Questions on that last one that I did? Are you enjoying this so far? No?
I like them.
You want to go back to organic? Everybody's different. All right, so the main tip I have from this is that 1 always goes with mole. The number of equivalents varies, so this depends on the ion. And 1 equivalent is equal to how many milliequivalents?